Hi, everyone. Welcome to Iowa State University of Industrial and Manufacturing Systems Engineering. This is IE 441 for the spring semester of 2024. My name is Chris Arevalo.
I'm David Berendt.
I'm Carter Bloomquist.
And I'm Michael DeCook. And we are working with B&G Foods on a project to improve line 20. Stone Spices, which is a B&G Foods subsidiary, is a spice company located in Ankeny, Iowa. The focus for this project is on line 20, which packages 4-ounce spice bottles. The objective for this project is to increase the throughput of the line by an additional 3%. Through the current state analysis, we found out that the focus of this project should be on the Doughboy, which is a machine that orients and packages bottles into groups of 6.
First, we started with interviews with operators, automation engineers, and maintenance staff.
With the data given to us by B&G Foods about the line, it was clear that the Doughboy machine caused downtime and should be focused on for improvement.
To validate the AS400 data, our team completed a work sample study on both the machines and operators of line 20. On the left is the document we created and used to log what the line was doing with the acronym seen on the right. This study was completed while the line was bottling Tone's onion powder bottles.
The results of that study showed that there was 53.2% of value added time, whereas the AS400 showed that it was running 100% of the time and validating the AS400 data. There's 46.8% of the time that was non-value added. For the operators, there's 13.95% value added. Non-value added but necessary was 53.2%, and non-value added was 17.8%.
Starting with the Doughboy statistical analysis, we observed when it works well. When it doesn't, it breeds other stuff. Through lack of product supply, high volume of missing labels resulted in a line stop, increasing the probability of incorrect bottles. One of the limitations that we found is that we only performed one formal observation of this study. Starting with the first solution, we had estimated this to cost about $1,200 in labor, materials, and applicable fees. This easy, low-cost solution retains the dimensions of the current block, minimizing cost to implement. The alternative to this design would be to have no change in the spacings of each sheet and purchase an identical block to reduce the jamming of the machine.
The second proposed solution is a finger cleat device. This motor-powered device will supply back pressure to bottles entering the churning block device. This will allow the Doughboy sensor to be brought closer, allowing the machine to run more often, contributing to a throughput increase. It will also free up line operators from having to manually supply back pressure, letting them focus on other problematic areas of line 20. This device will cost an estimated $10,000 for design, materials, and implementation.
The last solution is a new machine. We met with Syntegon, who is the new owner of the Doughboy, and they recommended the Case Packer 202, which will cost $175,000 and will increase throughput.
There are 2 different estimations of economic opportunities for the line. One for retrofitting the line using the new bottle turner and back pressure system. This has a cost of $12,200 and would improve the line by 1% based on findings and expectations of line 20 downtime. The profit increase is estimated to be $185,000. The new machine has a cost of $175,000 for the base model and will increase the line throughput by 2%. This is based on the increase in speed of the Case Packer 202 and has an estimated profit increase of $370,000. Thank you for listening.